Hello dear students, welcome to Tejama YouTube channel. So in this session, I'm going to give the detailed explanation for the concept that is parallelogram law of vector addition, and also I'm going to derive an expression for the resultant vector of two vectors A and B that we have considered here, and I will give you the formula for the angle made by the resultant vector with any one of the vectors that is considered here. Okay, now first of all, what does the parallelogram law of vector addition says? So according to parallelogram law of vector addition, we have the parallelogram law of vector addition states that if two vectors are represented by two adjacent sides of a parallelogram drawn from a point, their resultant vector is represented in both magnitude and direction by the diagonal of the parallelogram drawn from that point. Okay, now so what they are telling here is, let me consider it separately. Here we have two vectors. So the vector A is like this along x-axis. There is one more vector B which is like this. Correct? No? Look at this. Vector B is in this direction. Vector A is along x-axis. Now I need to add these two vectors by using parallelogram law of vector addition. In case of parallelogram law of vector addition, we join tail and tail of two vectors. Okay, this is the head of vector B and this is the head of vector A. Join tail and tail of two vectors. So if you join the tail of vector A with the tail of vector B, okay, so you will get this. Now let me draw a line. Here I will draw the dotted line which is similar to vector A or parallel to vector A, and one more parallel line for vector B. Look at this. This forms a parallelogram. So now A and B are representing the magnitude of two sides of the parallelogram, two adjacent sides of parallelogram. Then the resultant of these two is given by drawing the diagonal from the common point, that is tail and tail, which is added from here to here. If you join a line, this is the resultant. This diagonal gives you the resultant. Okay, now what is the value of this resultant and what is the angle made by this resultant with R? So that I am going to find in this video. Okay, let us start with the derivation. First I will draw the diagram for parallelogram law of vector addition. Let me consider vector A is in this direction. This is vector A. So I'm joining the tail of vector A with vector B, that I can consider like this. Yes or no? Okay. Now let me draw a line which is parallel. You can draw a dotted line also, which is parallel to A, and then join this in this direction. So does it form a parallelogram? Almost. You can use scale to draw this. Here I don't have scale, I'm drawing it directly. So this diagonal, now if we draw from the tails of vector A and B, let me write this is B. Where is vector B? This is vector B. Now the diagonal to this parallelogram comes here in this direction, right? All the way to this side. I will just draw a line which is joining these dotted lines. This is the resultant and the direction is from the tails to this side. So let us consider the angle made by the two vectors is theta. Here two vectors is theta, and angle made by resultant vector with A is alpha. I'll find a relation for both of this. And now, before that, let me do some considerations. The consideration is I'm going to draw a perpendicular here and extend this line along the vector A. Now, let me give some names to this. Okay, that is, this is O terms. Okay, this is M, N, and this is P. You can use P or here Q like this. Now look at this. This OQ is parallel to PM. So can I write this is also B, having the magnitude of B. And we have PN and MN here. The angle between PM and PN will be theta. That theta is equal to this theta. Okay, this theta is equal to this theta. Look at this. Here we have a right angle triangle. From right triangle or right angled triangle, okay, which one is that? OMN. Dear student, do understand this carefully. From the right angle triangle OMN, we can apply Pythagoras theorem here. Can I write OM is equal to MN? So OM square is equal to MN square plus ON square. Okay, look at this right angle triangle OMN forms a right angle triangle. Here the angle will be 90 degree. Why I am doing all this? To find the value of R and to find the value of alpha. I need the value of R and I need the value of alpha also. What is this alpha that I need to find? Let me take this triangle. From the diagram, there is a triangle that is PMN. From this, can I take sine theta is equal to opposite by hypotenuse? What is that? MN by PM. Correct, no? MN by PM. What is PM? MN by PM is nothing but B. So therefore, what is MN? Just multiply B to sine theta. That is B sine theta. This is equation number 1. Then from the same triangle, if you take a cos theta, you will get adjacent by hypotenuse, that is Pn by Pm. Pn by Pm. So Pn divided by Pm is B. So from this you will get Pn is equal to B cos theta. B cos theta. This is equation number 2. Okay. Now, if I substitute these values in this Pythagoras theorem, okay, we will get the final answer. So OM value I know, OM square, that is R square. OM value is R. That is equal to, what is MN? MN, that is this one, B sine theta. Look at this, we have. What is ON? ON is the complete base from here to here. Can I write MN as it is? I will substitute it later. ON can be written as OP plus PN, right? So OP plus PN whole square. If I substitute the values here, OM is R square. Look at the diagram. OM is R square. That is equal to MN. MN is equation number 1. That is b sine theta whole square plus OP. OP is A plus Pn is equation number 2, that is B cos theta. B cos theta whole square. So R square is equal to B square sin square theta plus A plus B whole square from A square plus B square cos square theta B square cos square theta A square plus B square plus 2AB into cos theta as it is. Correct? No? Now R square is equal to, in this equation, B square is common. First I will write A square plus B square is common. So if you take B square common, you will get sin square theta plus cos square theta plus 2AB cos theta. So what is the value of sin square theta plus cos square theta? It is 1. Therefore, R square is equal to A square plus B square plus 2AB cos theta. Okay. Then we have R is equal to take square root on both sides. You will get square root of A square plus B square plus 2AB cos theta. This is the derivation for resultant vector of two vectors A and B by using parallelogram law of vector addition. Simple derivation. Okay. Now what about alpha? What is the value of alpha, sir? Simple. You can take equation 1 and equation 2 separately. Let me take equation 1 is, that is Mn and Pn, right? Here I need, I have alpha value, right? Let me take the angle here, OMN as it is. I'll take the same case here. Right angle triangle. This is the resultant vector. This is, okay. This is the perpendicular Mn. And here in this direction we have ON. Okay. You can join it if you want. Okay. M, N. This is O. Look at this diagram. This is OMN, this triangle. So alpha is the angle. I need to find out this alpha. The value of R is given here. So I need ON value and OM value. Here we have P. Correct? No? From P we have drawn a vector. What is that? That is the vector B. O to P, the vector is A. Correct? No? Look at this. A, B, Mn, Pn, OP. This lower part I am writing. This will be theta. This will be alpha. And from the equation 1, we have Mn is equal to B sin theta. Mn is equal to B sin theta. And from equation 2, we have Pn is equal to B cos theta. Pn is equal to B cos theta. Correct, no? Okay. Now, I need to find out this alpha. So, what is tan alpha? Tan alpha is equal to Opposite by adjacent. Opposite how much in this right angle triangle? Mn divided by what is the hypotenuse? On. That is equal to, can I write it as Mn as it is, and On can be written as OP plus Pn. OP plus Pn. Therefore, tan alpha is equal to, what is Mn? Mn is B sin theta. OP is A, magnitude of vector A, and Pn is B cos theta. B cos theta. So now I need to find out alpha value, so I will take tan to the right hand side. So that is tan inverse B sin theta divided by A plus B cos theta. So this formula gives you the direction of resultant vector. Direction of resultant vector. Okay. What about the previous derivation? This R gives the magnitude of resultant vector. R is equal to square root of A square plus B square plus 2AB cos theta. This gives you the magnitude of resultant vector. Magnitude of resultant vector. This gives you the direction of resultant vector. Clear? This is about this derivation. Hope it is clear to you all. If you have any doubt, you can text in the comment section. So I will explain it. And if you feel the content is useful, please share it to your friends and make them subscribe. Thank you so much.